All right, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still building the tooling for Thyme development to facilitate the binary matching with unassemblize. Last video, we have started to implement accepting two inputs to this thing, and we got like halfway through, and now we need to implement this to-do function here. Okay, so where's the runner? Here, runner. Okay, so what we need is a struct yeah. Okay, let's first implement legacy behavior. Okay, so a legacy, we had these things here. Exe save float options. Okay, how about we call it disassemble options? Yeah, disassemble options. And we put this in here. And then we remove this disassemble option, and then we put a function. Let's call this process disassemble. Yeah. And then I put the const options O. Yeah. And then we put that here. Here. Process disassemble. Okay, and then we yeah, this works. Yeah. Okay, now here's a question. Executor. Yeah, executor. Executable. So we work with the first executable, and formats. Yeah. Mm-hmm. Formats. I don't think we need this here for now. Okay, so this would be like the legacy behavior. Yeah. So we can now read two PDBs or executables, but it will only disassemble the first executable with these disassemble options that we pass in here, which is output file format str start edges and edges. Yeah. Okay, let's implement this in main function. This is process disassemble. So we need unassemblize. Disassemble options, and then we take this here. Output file. Okay, that's input. Executable. Okay, this I don't quite like. So before we had input file from here, we don't have that anymore. file input. Okay, to me it looks like in executable we should store the exe file name. City string exe file name const city string get exe file name. Get exe file name do wonder we should omit the default. Okay, so here let's say runner.get exe file name, get output file name, input file. Okay. Yeah, this would work, I think. Okay, yeah. Okay, compiles. That's good. Okay. Okay, so we have implemented this functionality to have two exe sources. We have that. And we also have done this here. Yeah. Okay, good. Okay. Then I think we should also rename this to builds. Builds. Well, get. I mean, it's building it here. I guess. How about we rename this to get exe file name from PDB. Okay. Okay, so basically what this should do now is it should load both executable, but it should only disassemble the first one, the Thyme executable, which is loaded through the PDB, and just generate the file for that. So if we go to our Thyme.s and we erase it, yeah. If we run this now, it should generate our the program again, the assembly, the way we know it. Yeah. Okay, let's put a breakpoint in main. Yeah, let's put the breakpoint here. Okay. So our runner has executable. Oh, we made a mistake. I already see. Here. I do actually wonder what happens if we call read twice. What do we do in PDB reader when we read? We never approach it, right? This binary thing. Reads. I wonder. So right now, to me, it looks like we cannot ever like read the second file with the same instance, right? Output set verbose reads. Target objects. Target load objects. This is still used, yeah. Okay. Okay, I would like to do some changes here. Class PDB reader intermediate. And here we put this, 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 this. We use the same style and function. PDB reader intermediate. Um, do I actually need that for? Intermediate. But we don't really need that because we just have we just have 2 instances of this. Yeah, I think it doesn't matter. Let's just put it maybe down here. Intermediate structures used for reads, used during read only, during PDB reads only. Yeah, I think this is overkill here. For the function class, it makes absolutely sense, but for this, it's overkill. Just makes it too complicated. Okay, but what I would like to have is, I would like to have the clear function, void clear. And so in reads, we have that, clear, PDB, read, clear. So basically we just clear these things here. Clear. I mean, these things should already be clear. Do asserts dot empty asserts empty asserts not pointer. Okay, and then here we say compilance dot clear. Yeah, I mean, yeah, and then up here we call it clear. Yeah, I do wonder if we should like erase memory as well, or just clear. Well, for erase memory, someone could call the constructor of PDB reader again. So maybe clear is good enough. Functions clear, symbols clear, exe equals okay. What do we do if we read symbols? Ah, we already clear here. Okay, maybe we don't need a clear function after all. Yeah, maybe we don't need to do that. Loads. Because basically read symbols, it already clears here. Doesn't clear symbols though. Okay, then let's also clear symbols here. And mexe, maybe that should be cleared as well here. Yeah, maybe that is good enough. Then let's remove the clear function again. Okay, and in executable we should have it similarly. So we do read, But I think there is no cleanup here. Let's see. So binary is already changed here. Then we can say exe file name equals this one. And then section map dot clear symbols dot clear. This clear. This as well. And image data, what is this? Image data. Okay. Okay. Yeah. I think that works. Okay. PP reader. Okay, excellent. Okay, so our runner now has the executable file name is in here. It's not very pretty, but it is there. Game that. I wonder if we can pass the let me see, SCD file system. I've never used this. SCD file system build path. Okay. First pass. file system path. So in our util, we no main file system fs path std file system path how do we assemble this? Path equals would this work? Let me see if that compiles. That magically compiles. Okay, so and if we put a slash here and then this, dear slash file doesn't work. It's probably because I have to do pass equal this. No? I see. Return pass dot pass dot it returns a string, yeah. Okay, so I wonder if this gives us a clean path. Let's see. So basically what here is not clean is it builds a string with a slash that is not native to the operating system. I mean, it's not a big deal. Windows still works with this, but if we can make it a bit nicer, then I guess that would be cool. Let's see. Huh, that works. Oh, that works. That's cool. That's really cool. And so this should return that. Yeah, okay. I do wonder. Here this input file. Can we make it an absolute file? But I actually wonder, so this function, where is it used? It's just used here, get file path. I would imagine that file path also can do something to just put the path there, right? Let's see. File name. Root path. What does this return? Path. So basically we want to have debug now. Let me see. Oh, that fails. Parent path. Maybe that gives better luck. Let's see. Yeah, that's the one. Okay, that's cool. Parent path, and then we append this one. And this. Okay, that's cool. So we can remove this one, and that is much nicer. This also means we can remove this function here, this util function. Get file path. This one, let's remove this. Get file path. And then we remove this here. Okay, and then we can also parent path. Okay, so now the next question I have is, can we make a full path here? Like, let's say, oops, here, input file, get config file name. What does this do? Get file name without ext. Yeah, so I wonder. I think it's not necessary. Can look at this another time. Okay, let's look at this here. Okay, so we have runner, we have here debug Thyme exe game.pdb reader. Good. So output file is Thyme.s. Yeah, that's correct. Format is auto. Format is okay, we start address, end address. And then we go in here, and then it does that, and then executable, set output format. And then it dumps function to file. And now this should have written this, and it did. Yeah. And return true. Okay. Okay. This works. Great. Good. I think what we could also do is, I think in util CPP, we can probably get rid of a bunch of functions here. These functions, these two, with the help of file system, but we don't have to do this now. Yeah. Good. Then let's submit, if it's submittable, what we have. Disassemble options. I think here in PDB executable. Hold on, runner. In runner, I think this one we should put here in as well. Let's go. Max input files main. We can do const x size t max input files equals unassemblize max input files. Okay. Good. So let's stage this one. Executable. We added the exe file name. Getter. Here we cleared a bunch of stuff. And yeah. Okay, so we have input to type and config input type. Let me see, input type 0101 01 opt config 2. There's a mistake, yeah. Input 2, input 2. Config 2. It's a little bit hard to read this. How about we make it more obvious by putting it like so? I would argue that this makes it a little bit more visible. Config 2. It's beautiful code, I would say. Looks very good. Okay. Okay, so this looks good. Looks good. 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 Actually, I made the C++ fill array with value. I know there's std fill. First element, yeah. Fill n, yeah. There's no built-in way to initialize the entire array to some non-zero value. std fill. std fill n. Yeah, let's do std fill n. I think that's pretty decent. Because the problem I have here, if like this was changed, and this also would need to be updated. I mean, it's not a big deal, but it's kind of shitty that there's no automatic way that you can like specify just one. Like they could have done something like this, that you type some like 2 of these and then it applies to all, but it doesn't work like this, right? Yeah, I don't know why. Maybe there's some rationale behind this, but I don't see it. So what we can do is fill in auto str. Is that correct? Destination size and value. Yeah. Okay, this looks correct. Then we can do the same here. Yeah, I think that's a little bit better. Let's double check that it works correctly. So here we got empty strings, and now they are set to auto. Same here. Good. Okay, then we can update that. Good, so here we set the different input types, input files, and the different config files. That's correct. And here we have a loop now, and we do a lot of different stuff. Yeah. Oh, hold on, what was that? right. This. Okay, then we have intermediate structures used during PDB reads. Intermediate structures. Persistent structures. Persistent structures created after PDB reads. Yeah. Okay. Maybe we should change the style of the comments a little bit. Okay, that's fair. PDB reader with symbols clear. Okay, that's good. Okay, runner. In runner, we added this stuff here. And this stuff, yep. And this. Good. And then process this and that. We moved these to private. We have now 2 executables and 2 PDB readers. We have some new getter function here. Disassemble. Yeah, this is good. Here we added file system. Great. We have asserts here. How do we have asserts everywhere? Asserts. Runner. Here we have no asserts. Okay. Yeah, that's good. So we have all this. By the way, this to do here. Put a colon here. Okay. All right. Okay. Process PDB. Yeah. Disassemble. Yeah. Da, da, da. And this. Pass string. Yeah, this is good. Okay, so what we have done is we have provide give options for 2 executable sources. Give options. Give options for 2 executable sources. Give options for 2 executable sources in runner class, for runner class. And also we did properly clean state when rereading exe and pdb files. Properly clean state when rereading exe and pdb files. Give options. Properly clean states. Probably clean internal data when rereading exe pdb. What else did we do? There was one more thing here. Yeah, it's not worth this. Yeah, doesn't change anything. Give options for 2 executable sources for runner class. Properly clean internal data when rereading exe and pdb files. Yeah, I think that's the essence of what we did here. Yeah. Good. That is great. Then we can submit that. Yeah. Good. Then let's think about next steps. So we do already have a bunch more to do's here in our runner, the stuff. So we'll only get more work here. There was actually one more thing that I was thinking about earlier today, and that is in function H, we have this instruction data. And I think what we to do, let me see. Instruction. So there's a Zydus decoded instruction. Oh, it's huge. 3 to 8 bytes. That is outrageously large. It's also not well optimized here. Look at that. They could have moved these 2 bytes in here and saved 8 bytes in the structure. That's not good. Well, just a minor thing. Okay. Okay, that's a bit of a surprise that the decoded instruction is this large. So my thinking was perhaps we should not save the instructions as a string here, but actually save it as a decoded instruction. But now seeing the sheer size of this decoded instruction, it's kind of ridiculous how large this is. Yeah. It is kind of large. Because so the problem is this instruction string, it takes away a little bit of freedom. Like for example, we don't really understand what this instruction is made of, right? It doesn't have individual parts. The parts are separated by space, right? That let's look at this. let's remove this to-do for now. So when we have here this append this text, yeah, let's put a breakpoint in here. Let's build. And then put a breakpoint here and wait for it to hit, and it did hit. And then we have our watch here, and we put our instructions here, and then we see that we have lots of knobs. Like here, for example, we have a test byte ptr comma value. So like this first word is one part of the instruction, then all this from byte pointer till this is the first operand, and this is the second operand. So I mean, it's good enough to like left and right compare just text. For that it works, but we lose a little bit of information, right? So I wonder if we can have it better, but I don't know an elegant way to do this. Decoded instruction is just so large, and it's also too complicated. It would be nice if it was broken down into like a vector of strings, for example, or a vector of things. Vector of things, of simplified, like a broken down instruction set that is much simpler than what it really is. Basically, you just have I don't know. The thing is that labels are baked in here, right? JZ short lock is baked in label, right? Which still works for comparison. So whenever we make a comparison and there is this lock, and then left and right we have two strings, we compare it. We can say, okay, when there is a lock underscore, then we don't compare this guy, we just continue after the number is finished, and we continue comparing. Yeah, I mean it works, but I don't know. Well, I guess it's fine to have like a simple result first. Like this string instruction is like a really simple thing. So maybe if we can make it work for this, it's good for starters. And if we then have a better idea to do this, then we can upgrade those pieces of code, right? So we can keep it the way it currently is. And if we want to change it, we can still change later. Let me put it to do here. Think about how to improve instruction information to preserve a little bit more information how the instruction is composed. Think about how to improve instruction string slash data to preserve a little bit more information of how the instruction is composed. Slash symbol address symbol address operands, etc. By the way, we should probably... Did we submit already? I think so. We have added a lot of to-dos already. I would say we put a hash in front of it so it becomes bold. Okay. Good. Stop debugging is. Yeah, I mean the way it currently is here, it works, right? So this will work for our needs, but it is a bit weird. It's a bit weird. Basically, if we want to like change the way the instruction is composed, then we need to then we need to run disassemble on the whole function again, right? Like we could just we couldn't just run the disassemble custom on but this takes disassemble instruction. Decoded. What does this do here? Let's see. Disassembled instruction. Huh. Where's this decoded instruction thing? Disassembled instruction. Huh. Decoded instruction contains disassembled instruction. What is this? What is the difference? Hold on. General information about the decoded instruction in machine readable format. Well, part why this thing is so big is because there's this text thingy here. That sucks. Disassembled instruction. Okay, so we have a disassembled instrument. What is this? Whoa, it's so big. Holy shit. So it contains decoded instruction, decoded operands, operand count, decoded instruction. What is in here? Decoded instruction raw. So the decoded instruction, it does not contain any information about the operands. Detailed info about different instruction paths. Well, there's value in here. Disassembled instruction. Instruction operands. 10. What? 10 operands in there? What the hell? 10. Holy shit. Yeah, I'm not surprised anymore why this is so big. Instruction. And this is quite mad. It's 1200 bytes. Boah. 1200 bytes. Let's look at this. Okay, so info is decoded instruction. Fair enough. Operands. Holy shit. Okay, this text down here is kind of useless. Well, this could probably be hacked away. Like, we could make a copy of this. I don't know. Let me see. Let's ask ChatGPT. According to Zydis, the maximum amount of x86 instruction operands of x. According to Zydis, the maximum amount of x instruction operands for an x86 instructions is 10. What instruction would have so many operands? Let's see. It is extremely rare to encounter instructions with anywhere near 10 operands. Citus allows AVX 512 instructions. AVX vector multiply instruction. Safety margin. Okay, can you give some examples of x86 instructions with many operands? 2 to 3 operands. Okay, so I think what we can do is well, it doesn't really well, okay, so basically every time an operand is, so we have one command at the top, at the front, and then some argument, operand, comma, next operand, comma, operand. Okay, so if we have a text of an instruction, we can say the first word is always the instruction name, then comes the first operand after the space, then comes the comma, then the operand ends, and then next operand, comma, next operand, done. Yeah. So I think even if we have a text, we can separate the instruction into different parts. How about we create a helper function for this right now? Append this text. Void split instruction text. So we create a, let's do std array, std string, then we also do 10. Array. instruction. Split instruction. Append as text. Split instruction. Let's put a description. Splits instruction to array. Splits instruction text to array. Mof divert ptr eax comma 0x10 becomes how do we write elements for array? Mof divert ptr eax. I'm not sure if it's written like this, but let's go with this for now. 0x10 Okay, how would we implement this? Let me see. Split instruction. Size t words or counts 0. Char const char p or c instruction cstr while CSTR is not null, I see, it's not now. If count equals 0 and C equals space, then continue. It's a nice exercise for algorithm. So if count equals 0 and C equals space, then plus count and continue. Else if, well, let's do a switch. No, not a switch. Let's do if count equals 0, if C equals that, then we do this. Else if whatever's in there. Else if, well, we don't need the else if, just else. Then if C equals comma, then we do this. We could also do, change this. I think that's simple enough. Okay, and then we say here, so these are our terminators. Wait, we need to do also C. We need a 4. Put this here and we put C plus C. And then we say array count dot push back C, right? No? What's the problem? Else so if plus count equals 10, then break. Oh, we can put an assert as well. Assert count smaller than array dot size. Okay, remove this. What's the problem here? Incomplete type. Oh. So includes array. Array count, pushback. See, I think that's all we need, no? Let's make try run here. So we have instruction here. Yeah, let's make a run here. Split this. We have array. Instruction. I wonder if we should change the name of this thing. Instruction text. How about we call it ASM? That would be simple enough. ASM. Well, somehow that gives us errors. Why? What's the problem? Let's say. Oh, okay. So it looks like ASM is some reserved words. Okay. Well, then let's call it ASM text. I don't know. Or just text. Label text. Okay, let's give this a try run. See if that works. Okay, so it should split it into call and then $E9, right? Let's see. I wonder if we can optimize this further. This if count. If count. Yeah. I think we can, like, so the problem is right now it has to do two checks, right? It first has to check if count, and then it checks this, right? So there's probably a way to optimize this further. We can say char sep. So the sep starts with this. And we say, right, we say if sep equals this, if c equals sep, and then if count equals 0, then we change the separator to comma. Yeah. We put the assert here. Then we remove all of this and remove this. And voila, it's greatly simplified, but it's more efficient. It's simpler, it's more efficient, and easier to read. Great. So the separator starts with space, then goes to, if a count is 0, it switches to comma, and then it counts up here, check asserts this, then it continues. Yeah, I think this is much better. Let's test this. Separator 20. Okay, push back. Push back. Push back. Push back. Okay, now we have a separator, space. Separator changes to comma, count plus plus. Assert, continue. Okay, and now we will write to the second word. So we have call, and now it writes the second one, and then it will be done. And now we have call this. Perfect. Simple algorithm. Let's find a longer one. Nope. Nope. Here, this one. So this should be also just 2 words. Push and offset off. Yeah, let's see. Let's just go to the end. Array, push, offset off. Yeah, perfect. Let's test another. This should be 3. Moth, dword ptr brackets, comma, then the next one, offset, critical section. Let's see. Perfect. Oh, no, we have a problem here. Aha. Aha, aha, aha. So there's a leading space. Yeah. Leading space. what we can do is we can do here while while C+1 while C+1 is space, then while while C+1 is space plus plus C. So it checks like, is the next character space? If yes, count one up. Does that make sense? Let me see. Okay, here we have such a case, yeah. Okay, so C+1 is space, yeah. So it counts up C. And here it stops counting up. And now the word starts with offset, yeah. Okay, this should work. And now we have 3 clean words. Yeah, so this we can do. Maybe we add a comment here. Omit spaces between operands. Omit spaces between operands. Maybe we make put it here. I think here we actually don't need to change, we just move change separator after instruction name. Change separator for operands. Increment index. Maybe we call this index. Words index. Okay. Yeah, this is pretty good. There's only one condition here at the top, otherwise pushback. The pushback is not so cheap because yeah, there's quite a lot of things in here. Yeah, but it's the simplest way of doing this. Yeah, that's fine. That's fine. Good. Yeah, this is a good algorithm, I think. Split instruction. Yeah. Okay, so that means we can actually split our instruction into individual parts, which might come in handy later when we do comparison, so that we can see which part of the instruction is actually mismatching. I mean, it's not so important, but it's nice to have, I guess. We will see. Just have it here for now. Yeah. Okay, let's remove the test string here, this one. Okay. Good. All right, then what's the time? 2 hours 6. Yeah, I think it's a good time to take a break. Then I wish you a great day or night. Until next time, goodbye.